If a sequence has a limit point, then it must be unique. The sequence cannot converge to two different points. But why can't a sequence converge to two different limit points? It comes down to two things: the definition of limit and the separability of points. What is separability? Let's consider a metric space with a metric d. Separability means that any 2 points, regardless of how close they are to each other, they can be separated by 2 open balls that contain them and are disjoint. In fact, given points P and Q, the open balls centered at them, with radius equal to 1/3 of their distance, are open and disjoint. For why they are open and disjoint, recall the definition of open ball and the triangle inequality. So let's see how separability and limit definition imply a unique limit if it exists. One can show this by contradiction, assuming a sequence has 2 different limits. By separability, there are disjoint balls centered at P and Q. By the definition of limit, there is an index n1 from which all the terms of the sequence fall into the ball around P. But there is also an index n2 from which all the terms of the sequence fall into the ball around Q. Taking the largest of n1 and n2, we found an element of the sequence at the intersection of the 2 balls. This contradicts the fact that the balls are disjoint, proving that there can't be 2 different limits for a sequence.